Pre-calculus Unit 2, Day 28. This is Part 4. Very similar to what we just did in Part 3. So we have some functions, and we want to take these equations and we want to go through and do the composition of functions using these f of x, g of x, h of x, and p of x. So you can either keep going with the video and write down what I wrote down. Hopefully you can follow step by step, or you can attempt them and then see how you did and change if anything was incorrect. All right, so we'll take a look at them in a little bit, and hopefully you try these, and we'll go over all these in class. Anything you have questions on. Remember, start with the inside most function. And the only difference is we are not substituting in numbers for x. We're just trying to find these as new functions. So we're trying to combine two functions by not adding, not subtracting, but by taking the composition of functions. So for example, part A, every place I see an x in g, so g of x, I'm going to substitute in h of x. Where on the previous page we were putting in 3 or -1 or 7, but we're just putting in the entire function. Okay, so for these first two, and the nice thing was these are the same functions that we had on the previous page. So every place see an x in g, we substitute in the 1 minus 2x, we get -3x plus 5. Now we do g of f of x, so it's 1 minus 2x. Every place I see that x, I'm going to substitute in all of f of x, which is -x squared plus 3x minus 5. Then, again, that's the pre-calc. Now it's just algebra, simplifying. So we should get 2x squared minus 6x plus 11. Okay, on part C, um, we want to find f of g of x. So we have f of x, which is negative, which is really -1. I wrote the 1 in late. But -x squared plus 3x minus 5. So every place we see this x squared, we're going to put in g of x, which is 1 minus 2x. And then here in the 3x, we're going to put in the 1 minus 2x. So I'm writing an additional step just showing that 1 minus 2x all squared is 1 minus 2x times 1 minus 2x. So there's a couple ways we can do this. I'm just taking this -1, distributing it through this first parentheses. Some people make the mistake in multiplying it through both parentheses. This is just multiplication of three numbers. You just take two of them at a time. And now we can distribute this. So we get -1 plus 2x. So again, that's -1 times each term in here, then the 2x here, times each term, which would be another 2x, and then minus 4x squared. I had previously taken the 3 and distributed it to each and every term here. Plus 3 minus 6x minus 5. And the last step will be to combine like terms. So I only have 1x squared, so that'll be -4x squared. We have 2x and 2x is 4x, minus 6x is -2x. And for constants, -1 and +3 is +2, minus 5 is -3. So my final solution is -4x squared minus 2x minus 3. So for this one, every place we see an x, we're going to substitute in g of x, which is 1 minus 2x. And now I'm going to combine like terms. So 1 plus 2 is 3, so I get 3 minus 2x. And then 1 minus 3 is -2 minus 2x. And that'll be our answer. I could always factor out a -1 from the denominator. And if I take out a -1 from the denominator, then I get 2x plus 2. And then I would factor out a -1 in the numerator, and that'd make each of these signs the opposite. So both of those are solutions. Okay, and when you guys try E, F, G, and H, I'll put them in, and then we'll check any one of these that you guys have questions on in class. So for an E, you just substitute in what you know for H of X and F of X, then it becomes an algebra problem, just simplifying, combine like terms. Be sure to distribute the negative symbol to each and every term. F, that becomes f of x times g of x, and it's just the distributive property, and simplify, combine like terms. Move over to I. Now we're trying to find what values of x where f of x equals g of x. So just set them equal to each other. I bring everything over to one side, set it equal to 0. Combine like terms, simplify, but let's get our leading coefficient where it's positive, because that's more what we're accustomed to, factor, and then whenever you have two things multiplied together equals 0, at least one of them must be equal to 0. So x minus 2 equals 0, so that x equals 2, and then x minus 3 equals 0, so x equals 3. Last problem for g of x plus p of x, and again, that's another way of writing this notation. So in red is just g of x 1 minus 2x plus 2 over x minus 3. You need to have like terms, so we multiply by x minus 3 over x minus 3. Um, Again, distributive property, and I probably should write that is in parentheses. I didn't put that before. So distributive property, that's everything. In the first one, there's the x plus 2, then combine like terms, and we just leave it as a fraction. Okay? So those are your day 28 notes. We will talk about those in class. That is dealing with composition of functions, and we will have some time to practice day 28 homework in class as well. Thank you.